Hello girls! Today we will solve the Motion Unit 2 review homework worksheet together. So, the first question is, what is the difference between negative displacement and positive displacement? I will draw a little sketch for myself and think, what is displacement anyway? So, displacement is the change of a position of a point, which means that the difference between negative displacement and positive displacement is a point with negative displacement is a point that moves toward the negative direction on a number line, and a point with positive displacement is a point that moves towards the positive direction on a number line. What is the difference between displacement and position? So as we said before, displacement measures the change in position, while the position of a point is just where the point is on the number line, the location of the point, whether it's to the right of the origin or to the left of the origin. Okay? So position of a point is the point's location on a number line relative to the origin, while the displacement is the shortest distance covered by the point in a specific direction, or the change of position in a specific direction. Let's move to number 3. This is a free fall problem. So, since it's a free fall problem, I will draw my number line vertically and take the positive position upwards, and I will start reading and writing what I know. So it's thrown vertically down, so this is something we really need to pay attention to. The initial velocity is negative 0.5 meters per second because it's pointing downwards. It takes it 1.25 seconds to hit the ground. So the time is 1.25 seconds to hit the ground. Let's put the ground here. This is what happens. Okay? So from the initial point to hitting the ground, it takes the ball time equals to 0.5 seconds. And how far does it travel? The question is, how far does it travel, or what is the displacement? So the question is, how far does it travel? How far, or what the displacement? Is there anything else we know? Yes, this is free fall problem, so we do know that the acceleration is negative 9.8 meters per second square. The first step is to think of the equation to use. So we put the equations in front of us, and I will look for an equation that gives me delta y, which I want to find. So the first choice, I have v, I have t, I have acceleration, and I have t. So I can use this equation. I copy it to my paper, and I substitute. Delta y is what I want to find. It's negative 0.5 multiplied by the time, which is 1.25, plus half multiplied by the acceleration, which is 9.8, multiplied by the time, which is 1.25 squared. First, I multiply 0.5 by 1.25, and the answer is negative 0.625, and then I square the 1.25, so plus half, negative 9.8, 1.56, and I continue by multiplying the half times negative 9.8 times 1.56, I get 7.64. You might get a slightly different answer because of rounding. And the final answer, when I add these up, is negative 8.27 meters. So delta y equals to negative 8.27 meters. I take a minute to examine my answer. I used only 3 significant figures because they gave me 3 significant figures. My answer is negative, which is logical because it's traveling downwards. If it was positive, which would have meant that it's traveling upwards, that would be suspicious. 8 meters looks logical, so I let it pass, and I can add that the ball travels 8.27 meters downwards, but this is sufficient. Now I move to question 4. This is a multiple choice question, so on the quiz you don't have to show your work, only because it's a multiple choice question, but I will do the work on paper just to explain to you. The question says, the graph represents the motion of a student in line skates. The speed of the student in meters per second is, so I'm trying to find the speed, which is the same as velocity but without direction. They didn't give me the direction. That's why I don't know the direction and I can't call it velocity. So the formula for velocity is delta x over delta t. Or in other words, the velocity is the slope of the xt graph. This is the xt graph. Alright, so I pick 2 points. These are my 2 points. It will be x2 minus x1 over t2 minus t1. So my first point and my second point are here. My second point, x2 is 60 centimeters minus x1 is a 0. T2 is 6 seconds and T1 is a 0. So 60 centimeters over 6 seconds, velocity equals to 10 centimeters per second. And finally, fill in the blanks. If the motion has 0 velocity, then the slope of the position versus time graph. I will draw a little position versus time graph for myself. They say the motion has 0 velocity. Velocity equals to 0. Can the velocity represent anything on the position versus time graph? Yes. The slope of the position versus time graph actually is the velocity. So if velocity is 0, then the slope is 0. And I will fill that in. If the motion has constant acceleration, then the slope of the velocity versus time graph is, okay, I think, what is the velocity versus time graph? I will draw a little sketch for myself. Velocity versus time. Now, they say that the motion has constant acceleration. A is constant. What is the slope? So what is the slope anyway? The slope actually is the acceleration. The slope of the velocity versus time graph is the acceleration. So if this acceleration is constant, then the slope is constant. And finally, when the slope of a position versus time graph is negative, this means that who is negative? Well, the best is to think. We need to think. What is the slope? Pardon me for that. What is the slope anyway in the position versus time graph? In the position versus time graph, we can find the velocity from finding the slope. So, if the slope is negative, then the velocity must be negative. And it would be inclined